electric flux and the details about it. Now let us go to the next topic, which is known as the Gauss theorem. Gauss theorem in electrostatics is very important because by using this Gauss theorem you can find the electric field due to different types of charge distribution. In last class I have told you there are three types of charge distributions. For all those three types of charge distributions you can find the electric field. So before you apply the theorem, let us just try to understand the statement and the proof. Let me remind you, the statement is there in your syllabus. However, this proof is not within the syllabus, but you need to know how this theorem arises. This proof may not be the part of the syllabus, but you should at least know how it arises. So let us begin the class with Gauss's theorem. According to this theorem, when you have a charge, let us say Q, it may be point charge, or 1 point charge, or 2 or 3, it doesn't matter, but for the time being let us say only 1 point charge Q is there. Then over this surface, over this charge, there is a surface, let us say a spherical surface. Spherical surface is there, and at the center there is a charge Q. Then by definition of your electric field lines, it should be coming out of the charge or towards the charge. Let us say if the charge is positive, the field lines will be passing through the surface radially outward. For a point charge, positive point charge, it comes radially outward. From the property of electric field lines, you have already came across that the electric field lines comes out radially outward. That's why when you have a particular spherical surface surrounding the charge, then there will be a fixed number of electric field lines. That particular number of field lines is what is going to be stated by the Gauss theorem. Okay, aduna electric flux haibado high flux kanada laigadawa haiba surface da phawada electric flux haibadi total number of electric field lines passing through this surface. That is what is going to be given by this Gauss theorem in electrostatics. So let us go to the statement of the law. According to this Gauss theorem in electrostatics, what you are going to say is the total electric flux linked with a surface and enclosing a charge is 1 by epsilon naught. You must listen very carefully. Is equal to 1 by epsilon naught times the total charge enclosed. Okay, that means the total electric flux phi, this will be equal to 1 by epsilon naught times the charge Q enclosed by the surface. Aduna, the Gauss theorem, let me remind it again. According to the Gauss theorem, the total electric flux, the total electric flux linked with a surface is equal to 1 by epsilon naught times the total charge enclosed. And the surface amagi manungda laigadoba charge to be magi flux to madu do kai gamana ni haba 1 by epsilon naught times haibadi 1 by epsilon naught siga kai ga multiply tawani haba manung da yawiba charge q du ga multiply tawani haba. This is known as the general statement. This is known as the general statement of what? Gauss theorem. Okay, this is known as general statement. Let us remind it again. The total electric flux, electric flux linked with the surface amada electric flux 1 by epsilon naught siga manungda laiba charge q du multiply tawa manani haven. This is very simple. Okay, then after this general statement, let us come to the integral statement of the law. Integral statement the last. Let us see how the integral statement is. See, in the last class I have told you E vector is this phi is equal to E vector dot lower surface integral of E vector dot ds vector. I have told you this definition in the previous class. Then this initially your phi according to Gauss theorem it was 1 by epsilon naught into q. So instead of phi you can replace by this term on the right side. Then how will it become? See kailani closed surface integral E vector dot ds vector is equal to this on the right side. So this becomes the integral statement of Gauss theorem. This is known as integral statement. So when you are asked in exam to give the statement of Gauss theorem in general form, you should write the previous one, and when you are asked to write the Gauss theorem in the integral form, you should write the second one. Got it? Then let us go to the proof of the theorem. For every theorem, you should know how the proof arises. Although it is not a part of the syllabus in our council of higher secondary education, you should at least know how this theorem arises. So let me go in brief how this proof can be done. Suppose you have a charge q here. Then if you take a surface surrounding this charge, spherical surface, and if the radius of the surface is r, and if the charge is positive here, the electric field line will be coming radially outward. This will be the electric field, direction of electric field intensity. Magnitude as well as direction will be given by E vector. Then if you take a small area here, ds, then by definition of area vector, it should be perpendicular to the surface. That means in the same direction is ds vector. What is ds vector? Area vector corresponding to the small area ds. Then let us start the proof now. Magi consideration assumptions then from the expression of electric field ki expression see point in the center is O haro, see point in the P haro. Then at the point P the electric field E do masi kaligamane. As you try to recall, 1 by 4 pi epsilon naught q divided by r square. This is electric field due to a point charge. When you have a point charge q at the distance r, you have this expression for electric field. Similar is the case here. This is the first formula that you should remember. Then let us find the total flux now. Then let us start with the definition of electric flux in integral form. E vector dot ds vector. This is from the definition of electric flux in terms of integration. Then let us take the dot, expand the dot product now. Dot product expand our say E ds cos angle kya lani? ds vector and e vector, they are in the same direction. Same direction the line na kailong tare 0 lani cos 0 natra cos 0 value kya no 1 ni natra adi taragadi sida kedaure close integration e ds khatangai cos 0 can be removed. I hope you can understand up to here. Then ekoi kedaurni have kanda this e can be taken outside the integration. Integration from the rule of integration, when you have a constant, you can take the constant outside the integration. So this will be e close integration ds. Ko e di amuk kari ka mana kre sigi equation sidagi 1 by 4 pi epsilon naught natra q divided by r square. This is the substitution of electric field from this equation. Then integration ds to kari tarakani have kanda. Say yung asai surface ni lai do ds side no sigumba area macha mani. This small area is ds. Ko small area is ds ni. Adu oiba taragadi side small area ds se koina integrate to wide kaino loin punsin ba haibane. Integration ka to ba my consequence kaino punsin ba. If you sum up all this area on the surface, then it will give the total surface area of this sphere. If the radius of the sphere is r, what is the formula for surface area of a sphere? If the radius is r, area is 4 pi r square. 4 pi r square ni. Ado iba taragadi nang sida integration ds ki mata kailani 4 pi r square, because your integration ds, close integration ds will be equal to the closed surface area 4 pi r square. Then adu taragadi kari lemore 4 pi cancel tawre natra adagi r square ga r square siga cancel chale ri kai lemore 1 by epsilon naught into q lemore bra. Therefore your phi is equal to 1 by epsilon naught times the charge q hydrotara breo. Tareko aduna, so this proof is completed here. That is, the electric flux linked with the surface is equal to 1 by epsilon naught times the total charge enclosed. Alright, I hope you could understand the proof of the Gauss theorem now. So in the next classes, you will learn how to apply this particular theorem to certain situations. Now, let us come to the first application of the Gauss theorem. The first application of Gauss theorem, application of Gauss's theorem. In your syllabus, the first application is infinitely long linear straight wire which is uniformly charged. Let us see. Now you have a straight wire like this. Straight wire is there. Then you have this positive charges distributed equally on the surface. Okay, and the total charge enclosed by this enclosed on this line is Q, and the length of the line is L. Let us say Q is the total charge and L is the length of the line, like this. Then we are going to find the electric field due to this line charge, linear charge. Then to apply the Gauss theorem, we should draw an imaginary surface which is known as the Gaussian surface. This Gaussian surface will be drawn such that at any point on the surface the electric field is the same. Electric field is the same. Then if you draw, say if you imagine this each and every point on the line to be the source of electric field, then there will be small circles. When you combine all those circles, you will have the shape of a cylinder like this. So the length of the cylinder, this length is, let us say L, small l or let us say, and the total charge enclosed inside this cylinder is small q. Then to apply the Gauss theorem, you have for a cylinder, series cylinder, sina hydro charge distributor with length L C pull up and close our record. Other target hydro Gauss theorem pan be then you have surface 1, so nakangi mamayama, surface 2, so nakangi mamayama, then the lateral surface 3 hydro. So you have 3 surfaces of the cylinder for which the area vectors will be different. Aduna som nakangi ahan bagi say idalay gadawa area vector C som nakanda smile lane area vector, as you know, is to be always perpendicular to the surface. So this is ds1 vector. Okay, then for the second surface, the small area will be, area vector will be ds2 vector. This is also perpendicular to the second surface. Then the third surface, perpendicular to the third surface, this will be taken as ds3 vector. ds3 vector. Here we go. Let us try to draw the electric field intensity now. As the electric field to be point to be electric field to be, it should be radially outward. I will mapal mathang from the spine chalani. This is electric field, E vector, electric field intensity. Likewise, here also by definition of the Gauss theorem, Gaussian surface at any point electric field, that's why this should also be E, and this area vector, this E vector will be the same here also. So this E should be the same. Okay, the Gaussian surface, as I told you just now, should be drawn in such a way that at every point on it the electric field is always same. That's why I wrote E here, E here, E here. Okay, so I hope you could understand how the figure was drawn. Now let us start the proof. So by definition of, if charge Q is enclosed here, your line charge density lambda, this is equal to Q divided by L, Q divided by length L. Then how much should be Q from here? Nang silay Q buthodi kya tarni? Lambda into L. Let this be the first equation. Understood? This becomes the first part of the derivation. Then let us apply Gauss theorem. Gauss theorem applied to by Gauss theorem, we have closed integral form to the E vector dot ds vector is equal to 1 by epsilon naught times charge q. 1 by epsilon naught times the charge q. So integration is done over the whole surface. All 3 types of surfaces are integration. Integration E vector dot ds1 vector plus second E vector dot ds2 vector plus E vector dot ds3 vector equal to 1 by epsilon naught into sida ngasai aina lambda do q do kari ga manakre lambda into l ga manakre. Let us substitute it here. Yareko amuka hana hage this integration is over the whole surface, so this integration can be distributed into 3 components for the first surface, second surface and third surface separately. Then you substitute instead of q here by lambda l. Understood? Then let us continue the simplification. Simplification do koi continue tawar se karam haina lake have the yo mai lake have the yo si lagi sano ds1 se or si makha de som lake se how is e vector and ds vector angle kya lai mo ani mata angle 90 degree lai natro aduna ke dawani integration e ds1 cos kaya 90 natra. Second is ds e ga ds2 ga do angle 90 lai ramani same perpendicular hoibani na, so similarly e ds2 cos 90. Second term bo koi simplify ta bol re. Third term gi e ga ds ka se direction kamai lai third sidadi same they are in the same direction. Then the third term will be e ds3 cos 0 ko right side ti kaya lai lambda l divided by epsilon naught natra. So out of these 3 terms you will have only one term remaining. Term ama khatang remain tawani. First cos 90 0, first and second term will vanish. Cos 0 1 ni. Then c khatang ai close integration ds3 is equal to lambda l by epsilon naught. Then integration ds3. Integration ds3 se yo ds integration se ds3 se integrate hota agadi sigi lateral surface area pamoidra. Sigi lateral surface area of the cylinder. Matra lateral surface of the area of the cylinder the formula kaino sigi mamai sigi mai circumference ki 2 pi r am lai re mai asangba sigi cylinder sigi spherical area do 2 pi r siga length aside the length of the cylinder l siga manadin. This gives the lateral surface area A. Ko lateral surface area ni adu ta agadi nam sida kai thamani e into 2 pi r into l equal to lambda l by epsilon naught kari kan na yare l ka na yare. So your final expression for the electric field due to the linear straight wire will be equal to E equal to lambda by 2 pi epsilon naught r ka manarani hai. So this is the final expression for electric field due to a straight linear conductor. Right? This completes your problem.